Now we've written a low-level ON component, which is also called middleware. It's called middleware because it sits in the middle of a processing pipeline, and there might be components ahead of it in the pipeline, and there might be components afterwards. Our component didn't care about later components. It simply wrote out a response and returned a task without calling into later components. But we'll write a real component shortly that does act more like middleware. Now you might say, this is a lot of work just to write hello world, and I didn't even have caching or membership features as yet. But remember, a goal of Katana is to be as lightweight as possible. So we really are running on almost bare metal here. Well, except for the core of Katana and the CLR and the operating system, we do have a web application though that is about as small as possible. And not every component has to be a class. You might remember the first sample used app.run, which essentially provides a wrapper for an app func so it plugs into the pipeline. So all we needed to do was pass in a small bit of code and that gets plugged into the pipeline. We passed in a bit of code that just took an environment variable and it wrote out hello in the response. Now you might look at that piece of code and wonder, where did this response object come from, environment.response? Because in the low-level sample that we just looked at, all we had was a dictionary of objects. I had to pull out a response stream manually and wrap it with a stream writer to do anything useful. Well, the run method is an example where a framework like Katana can build on top of ON and provide some features and classes that make it easier to work with. The run method is a great example of this because I don't need to worry about the next component in the pipeline. All I need to do is pass in a function. Something behind the scenes will take care of calling the next app func. And I also have more objects available than just the dictionary of object and string. Instead of working with a dictionary of object and string, the run method has some code to pull out objects from the dictionary and make request and response objects available. So now my code doesn't have to do that, but behind the scenes there has to be code that works with ON at the primitive level by working against that dictionary of string and objects. And the ON specification lists a number of keys that must appear in that environment dictionary. Here are the keys associated with a request. So you can look at the request body, you can look at the headers, you can look at the path being requested, and that's where you could write some middleware that routes a request to some specific object that will render HTML or render JSON or whatever you need to do, but more on that later. And here are some keys related to the response. You can get to the stream representing the response body, as well as the headers and the status code, all the important things. So let's write some code and figure out exactly what is in the environment. Back in Visual Studio, let's write some middleware that will get registered before use hello world so it has a chance to execute. And to write this middleware, I will invoke the use method. Now the use method is overloaded. One version takes an ION context, and that's one of those nice abstractions that will break out the request and response for me. There's also just a version that takes an object, and that's when I want to drop down to the lower level and write something like the hello world component that we wrote earlier. But this version, I can just give it a lambda expression, some function that will take an ION context, and a second function that returns a task. And this is essentially trying to help me to write an app func method. So I need a lambda expression that will take the environment and will take the next component. And here's the body of that lambda expression. What I want it to do is loop through each pair in the environment.environment property, which is that iDictionary of string and object, and is essentially the context for a request here in ON. And for each key value pair, let's just dump it out to the console. So we will write out parameter 0, parameter 1. Parameter 0 will be the key, which is always a string. Parameter 2 will be the value associated with that key, which might not always have a good string representation if it's something like a stream, but at least we'll get the type name. And now since this is a true piece of middleware, it's just sitting in the middle to log things and dump out what the environment is, I need to chain processing to the next component in the pipeline. And one of the easiest ways to do that is to say, await this next function. But in order for that to work, my delegate, my lambda expression, has to be async. And with an anonymous method like this, I can just use the async keyword in front of the lambda expression. That will allow me to use the await keyword. So that's one piece of middleware. Let's write another one. Let's say app.use. This one also asynchronous. It takes an environment and the next thing, and the next component. And what I want to do here is just write out some specific information, something like requesting plus environment dot request dot path. So that's something that the use method and its abstractions will pull out for me. And then I'll await the next component so it can finish its work. And by the time I do that, this message, this request should have reached some terminal handler, some handler that has produced a result. It's writing HTML, it's writing JSON, or it's just writing hello world. So everything before await next is sort of the incoming request traveling through the pipeline and being processed. Everything after next is the response coming back through the pipeline. Of course, at both points you have access to both the request and the response, but the response status code might have been changed or populated at this point. So I could write out response is environment.response.status code. And the status code is something I could change and use hello world. If I wanted to return, let's say, a 404 for some reason, I could go into that dictionary of string and object, and I could look up environment sub on.response status code, and I could set its value to a 404 or 500, but the default is 200. The default of 200 is already populated for me, so I didn't need to explicitly set that status code. So now we have two additional pieces of middleware activated, one that will dump out everything in the environment, one that will explicitly just dump out the path being requested and the status code of the result. So let's try to run this. And it's up and running. We come back and go to localhost 8080, we'll get a lot of console output. So you can see the first bit of output here is related to dumping out the environment. The request path was /. There's some request header dictionaries. The response status code was already defaulted to 200. There was no query string. The method was an HTTP GET, and the protocol is HTTP 1.1. And if I scroll down through everything that was dumped out for the environment, we can also see some server-related variables. So you can see the local port being used, the local IP address. But down here at the bottom is our other piece of middleware, where you can see we've actually had a couple different requests here, because a lot of browsers, when they request a web page from any website, they'll send along a second request the first time to try to get the favorite icon for that site. In this case, we also returned a 200 for favorite icon, even though we didn't have one. So you might say, well, how can I respond to different requests for different URLs and images and so forth? We'll take a look at that scenario, but for right now, let me stop the server and come back and temporarily comment out this piece of middleware that's dumping out the environment. I really just want to show you that when I refresh this web page, we do get a request for the root of the site. The response to that was a status code of 200. We also got a request for the favorite icon. And right now the browser really wants to find that favorite icon. So every time I send a request to this local server, it requests the root of the website, but also the favorite icon. If I request something like /greeting, you can see we get a request for /greeting, also the request for the favorite icon. But the question you might have at this point is, if I want to build a real application, something that has multiple URLs associated with it, how could I differentiate between a request to the root of the website and a request to /greeting? I want those to provide different data. Well, that is what we will look at next. But for now, I just wanted to show you middleware and how it behaves. How we can take requests, plug in functions that act on those requests in a pipeline, and we can order and arrange them so that they get called in a specific order. In this case, I wanted this logging middleware to be registered and appear in the pipeline before use hello world. That gives it a chance to execute. If I were to reverse those two, then what we should see when I come back to the website is we get the hello but no logging. And that's essentially because the hello world component that we wrote never passes control to the next component in the pipeline. It simply writes out hello and it's finished. Whereas this piece of middleware does use await next to allow the next component to process the request. And it gets to look at messages as they come into the web server and as they go out, coming back through the pipeline.